for a mission through WV Bear. WV Bear stands for West Virginia Balloon Engineering for Atmospheric Research. It was a balloon engineering team that was based on the collegiate level, that was sponsored by NASA and the different space grants around, and headed by Montana University. The idea was that we will launch weather balloons during solar eclipses to try to measure certain scientific data. Our main mission, however, was to have a video downlink, and our main goal was to downlink that video so NASA TV could pick it up and put it out during the solar eclipse. Unfortunately, with a lot of cloud coverage and stuff, we weren't able to receive a very good video, and NASA TV did not end up using our feed, but we still got a pretty cool picture out of it. And I start that because how do you track a weather balloon when it's up in the sky?
Guessing APRS.
Yes, APRS GPS board that was capable of running on a weather balloon. Some of you might know that a GPS usually has lock on it that if it's going over a certain speed or if it's over a certain altitude to turn itself off because, oh my gosh, I'm an intercontinental ballistic missile. He found a module that, at least altitude-wise, did not have that lock on it, so we could run it on a weather balloon. A 19-inch piece of wire sticking out the bottom of the box had an APRS transmitter. It only transmitted at like 100 milliwatts, but because of how high it was, we heard it for like 400 or 500 miles radius from where the balloon actually was. 20 feet worth of rope on it with lots of things attached to it. We had some scientific, of course, a couple camera modules, but it was really cool because he designed it himself and he used it for that. And when the balloon project was over, we're like, well, that's awesome. We're glad you manufactured that. It was a really big help to us. Well, now what are we going to do? So he figured out a way that you can use the same basic Arduino base soft computer and software, but with a much cheaper GPS module and a little more simplistic wiring and a transistor or two. You can hook it up to a K connector type radio quite easily, like a Baofeng or a QRZ1. Some older Yaesus, like my Yaesu here, uses the Yaesu version of the K connector that's very similar. He likes K connectors because we're cheap, broke college kids. We use $20 radios, you know. He was able to translate it into that, and we have now this. The idea that we're building a little circuit board that's going to be about this big. It has, of course, populated. This is not populated. And it's going to be a APRS encoder where it will downlink a GPS signal and encode it and automatically transmit at a certain frequency through the push-to-talk through the remote speaker mic of a handheld or any other radio you want it to connect to, but we designed it for a handheld. But yeah, this is going to be the form factor. Pretty cool. We have little GPS antennas that are only about that big that go on them that came with the kits that work well when you're outside. If you want, there's also a pretty easy way to put it to a more mag mount, but GPS antenna like you might have on a car. I have one of these on my car because you need it. You just need a I don't know what the connector RP. U.FL. It's whatever is on standard Wi-Fi cards to SMA, and then just a standard like $10, if that is like a little accessory to your build, if you will. We didn't have that. We just were using the little things in there because for like in a backpack or hiking, which was kind of the original idea because this guy loves to ride his bike, it works quite well. So the idea especially for the new hams that we had, the freshmen at WVU, was to give you an experience to solder, especially there are a couple SMD components on the board, but it can be done with a soldering iron, supposedly. I haven't done that. I've never built this board physically, all of the pieces to make a working one. I've been told it's pretty easy. It just takes a little while. You just have to be kind of careful with where you put the hot end, but it can be done. So there's a few of them that are populated already with most of the SMD components on it, if you'd rather, but I don't have all of them as a SMD populated, so you might have to fight over it. Here's the schematic, if that means anything to you. It runs on an Arduino Nano, so that's the chip that you see on the left-hand side. It does have a variable audio level out into the radio via potentiometer.
Is the Nano socketed, or is it?
It's soldered.
soldered in.
We don't have a socket on it. There's only like 4 pins that it actually used that needs to be soldered. You don't need to like solder every single pin on it.
Okay.
And if you'd like to put a socket on it at some point later or something, that's absolutely. So whenever you guys are cool with looking at that, I'm assuming that you guys know most of the basics, but it's effectively multiple tones over a FM signal that makes a squawk that kind of goes, and that's data because of how fast the data goes through. That's basically all that he's saying here. Usually the tones that are at maximum around 2400 hertz because of the FM radio narrowband frequency limits that there is, and an Arduino runs at 20 megahertz, so it doesn't really care. It just kind of does it, and it's smart, and yeah. If we had an oscilloscope, you're able to look at it. You can probe it on the points of the boards, but if not, my usual goal is just plug it into a radio and see what it does. So, yeah. There is, like, here's some ideas that he said. The first one is exactly what I did because I'm his test bed. He doesn't have a car, so I'm his around town. You can put it on a GPS with an HT, with an external GPS antenna with a 2-meter whip. You can program it to send telemetry. If you want to go through the code, the code's all open source. He has all the updates on his GitHub page, which I'll show you guys in a couple minutes. But it has, because the Arduino has enough capability, you can, and the APRS standard has the capability, you can input serial data to the Arduino, and you can encode that and transmit that over the APRS. If you ever look at like APRS.fi, you'll see some guys with like weather stations or whatever that have like temperature or rainfall right in their thing. That's how they do it. You can send little messages on it. I think my message says like WHCUL build day, monitoring on 1.14652 or something like that. You can kind of make it your own. Of course, have to change your call sign. You can change your little picture of like your car on the thing, kind of like you can on certain GPSs. It's kind of fun. Like there's a train and a tractor. I'm a geek. But there's all kinds of different things you can do with it. You can make it standalone with battery. You can do et cetera, et cetera, et cetera. We're very happy for you to do stuff with it and play with it beyond what we're just going to build it and use it, if that makes sense. If you want to experiment with it, by all means. If you do and you make it work, email us and we'll add it to the GitHub. There is a minor correction in the schematic. Basically, you won't probably even notice a difference. The original schematic uses a 2N222 based transistor, and we found on certain radios it doesn't pull down enough back to ground, and it'll just keep transmitting. That we've replaced that with a BS170 MOSFET. It's a direct replacement, only it's a MOSFET now, and it just works. So I didn't even bring any of the 222s, so you don't have to worry about that. There's only one transistor on the board that you probably wouldn't even notice if I told you, but since it's here and since showing you the schematics and stuff, I absolutely want to show you guys that. We just drop it in just like you would anything else, and it doesn't care. We use KiCad to do this, and of course Arduino. We were totally funded by the West Virginia Space Grant Consortium, which is a subsidiary of like NASA in that area. They do a lot of stuff with the NASA IV&V facility in Fairmont. After we did our ballooning for the Montana and for NASA and everybody, we continued it as a club, and we just started doing it ourselves and doing smaller payloads of smaller balloons. And we didn't do much video, but just we have balloons and we like throwing things into space, so why not, right? We had a couple projects that unfortunately fell through. We were going to put an amateur television transmitter on it, which would have been cool. We did put a Meshtastic node on it and had a couple nodes around Morgantown to see if we could mesh all the way to space, and we did very well.
Oh, nice.
We were going to try to put a crossband repeater on it, and I don't know if we ended up doing that or not, but it was only going to be like a 1-watt repeater just to see how far we could make a contact.